All right. Hi, everyone. So, welcome. My name is Attila, and what I've been working on for the past, well, almost 2 years now is Oracle's new JavaScript runtime named Nashorn. It's a very interesting project to work on because implementing JavaScript on top of another virtual machine is, well, it has its challenges, to say the least. So this talk is unfortunately not really about those challenges. It's rather more about, well, it is actually, but it is more about things that we needed to do in order to make things feel nice and usable if you're coming either from a Java developer background and want to try JavaScript on the JVM, or if you're coming from a JavaScript developer background and want to try JavaScript, this time on the JVM. So let's get this out of the way. This is the I work at Oracle slide. What I want to tell you today is, well, this is our agenda. What I will be talking to you today, and will be presenting a lot of demos in a form of live coding, is if you actually set out and you want to use Nashorn, and you actually want to integrate with the underlying Java platform, what is it that you need to pay attention to? Because at the end of the day, Nashorn is really just a JavaScript runtime. If you are not using any Java-specific features, it is just an absolutely ordinary vanilla JavaScript runtime for ECMAScript 5.1 specification. As a matter of fact, it's a little matter of personal pride for myself that actually Nashorn was the first ECMAScript 5.1 completely compliant runtime ever. We undertook this project in the order of compliance first and then performance, which is something that we are still working on and making good progress on. But about a year ago, I remember there was in a particular bar in Stockholm where I had to bring my laptop with me because by 6 p.m. that day, I still didn't get to one of the 11.5 thousand tests in the ECMAScript spec to pass. That one test actually took me several days to get right because it actually underlined an interesting architectural problem. And the crew was moving to a bar, and I just took my laptop with me, and it was in that bar that I finally, for the first time in my terminal, I saw the message that 100% of the tests have passed. Those 11.5 thousand tests, they take a little bit while to run. So anyway, I digress. So if you want to just use it as a JavaScript runtime, you don't need to know anything. It's only really interesting when you want to integrate with the underlying JVM feature, want to interoperate with something in the Java ecosystem, which is pretty much the reason why you would use Nashorn and not some other JavaScript runtime, right? So the things I will not be talking about in this talk are specifically JavaScript. I will not be talking about the language. I suppose that if you sit in this audience, you already know JavaScript. I won't talk about how do you integrate Nashorn into your Java app, how do you embed it into your Java application, because that's that simple. You just use the javax.script package, and that package has been in Java since Java 6, back in the day when Mozilla Rhino was first integrated as a JavaScript runtime in the JVM. So I don't want to talk about run-of-the-mill stuff. I won't talk about the language. I won't talk about Java Xscript API. I will suppose you either know that or you will know how to figure it out. Java Xscript, as I said, it's a standard Java doc. You can find it. I definitely want to talk to you about the points where Nashorn exposes the underlying JVM. And these things apply to you even if you're writing a small script or you're writing a large application that you are embedding into some application framework, such as the Avatar.js. Who knows what Avatar.js is? All right, not too many hands. So Avatar.js is an undertaking within Oracle that was undertaken independently of the Nashorn team. We had some guys that just had this nice idea of, hey, what about we write an application server on top of Nashorn and the JVM? So they did. It exposes, well, node-compatible API. We are not supposed to call it anything with that word, though. So there is this URL. You can just Google it. Don't have to remember it. That pretty much everything I will tell you about can be found in a scripting guide. I'm just telling it so that if you don't remember something you heard here, don't worry. We are documenting stuff. So, and that URL is the usual scripting guide. So normal, simple things, right? Basic interop with Java objects. What we wanted to do is make the simple things very easy. For the most part, things work as you would expect them to. Don't pay attention a lot to the code. I will show you what does it do in a moment. So how visible is that? I guess it's fairly visible. Alrighty. So tomorrow there will be a Nashorn specific presentation that will be using JavaFX. I have to admit, I don't know JavaFX. When I was, back in the days when I was writing any kind of UI on Java, I was using the AWT, the very, very old ancient package. So that's what I'm using for the demos. It's not snazzy, it doesn't look nice, it doesn't have nice transitions, whatever, but yeah, it works. So what do you do here? It's you create a frame, create a very simplistic UI, and then there is an event handler here, which looks very much like you would do it in Java. You say you have a button, you want an action listener on your button, you pass it an implementation of the action listener interface. This looks a little bit JavaScripty because you are passing it an object literal that has a member that is a function named after the method in the action listener interface, and then you're doing something in it. Now, this hopefully runs and doesn't do anything cathartic. It just tells you, it just greets you basically. And if you press the button, you run the event listener. Hooray. The reason I'm using this very simple example is that I'm going to refine it for you now. So first thing that you can do, and if you're coming from a JavaScript background, this probably looks horrible to you because it's too Java-like, right? So how can you simplify these things? Well, one thing that you can do is that Nashorn actually knows that add action listener Java method expects a Java AVT whatever action listener, but you can also do other things. For instance, this action listener, we know that it is an interface with a single method, right? So you can, in sort of a lambda fashion, you can just forego the whole. Okay, you can just forego declaring the name of the function and passing an object. You can just pass a function as the constructor to your action listener. If I run this now, fingers crossed, hey, look, still runs. Okay, how can I simplify it even more? Well, the thing is that we also know that if a function, if a Java method such as add action listener actually only needs an interface that has a single method, you don't even need to deal with the whole new Java whatever. You can pass a function, and Nashorn will still know that what you are doing is you actually are specifying the behavior. So it will create an instance of this of an anonymous class that is delegating to this function. So you see, we're cutting code. And does it still work? Yay, still works. Okay. Still doesn't look too nice. One of the things that you can also do is, instead of a get text, you can just set text, right? So properties on Java objects can be specified and then default to getters, setters, and so on. So run this thing, and as you can see, whoa, still works. So getting the text works even if you are just doing a .text. In a similar vein, of course, your setter is not really necessary to be invoked as a method. If a property is named on the left-hand side, then we will just look up its property. We will just look up its property setter. So with these replacements, did I save it? Yes, I saved it, so I'm not cheating. Okay. Still works. Okay. And finally, this is the final refinement for this example. You can just take out this thing here and just say plus equals. Nice, right? So, still works. And what happens if I press it twice? Yeah, well, as you can see, it will work. Now, the nice thing about this plus equals is that it works for any POJO, any property. Well, it helps if you can somehow interpret the concatenation or the plus operator on that particular type of the property, but other than that, it just works. So this is now much simpler example here. We reduced this action listener quite a lot. But what else do we see in this example? If you now go back to the slides, we saw that you can create your Java objects, you can invoke methods, pass parameters. Parameters automatically converted from any JavaScript value to whatever makes sense in that parameter position. So if you pass a function and what is expected is a single abstract method interface, such as in Java 8 lambdas, Nashorn will know what you're expecting to do, and it will just convert and create all the proxies in the background and just put them there. Iteration, again, works as you would expect it to. If you have a Java array or any iterable, you can do either a for iteration or a for each iteration. Now, well, one thing that when you come to JavaScript, you have to pay attention to is that first line for something in colors. In JavaScript, that thing actually iterates over indices or keys, because in JavaScript, actually, you don't really have a distinction between keys in a map and indices in an array. Arrays are actually just maps that happen to have numeric indexes. Actually, it's even worse. In a canonical definition of a JavaScript array, keys are strings that happen to be parsable as decimal numbers. It's one of those things that it is very hard to implement this language and also like it. It's one of those sausage factory things that if you like them, never see what they are made of. Things that if you like them, never see what they are made of. So that said, basically for everything I have on a slide, I have a runnable program. So here's the equivalent program, and if I run it, then as you can see, it does what it says on the tin. So the first one will be iterating over indexes and retrieving them, and the second will actually iterate over the elements of the list. Now this works for arrays, list, anything that implements iterable. Iterating over Java maps, same thing. For iterates over keys of the map, and for each iterates over the values in the map. So same program. As you can see, it does what it's supposed to. The capitals are chosen as capitals of countries that I have lived in the past. Actually, one is missing, but that's just a small oversight. I would probably have to specify Washington as well. Now, interestingly, if you want to get a little bit more Java-like, what you can also do is you can take this guy here and you can modify it so that it says for each var entry in capitals entry set. As you can see here, we are pretty much mixing the Java API and JavaScript because you know that this is a Java map and you are then taking its entry set. And of course, you can just iterate over the elements of that entry. And then you can say entry key is entry value. And substitute this here, and it should still work. It should still give you an identical output. So you can, when you know that you're working with your Java APIs with Java objects, you can fully rely on any methods that those maps have, any POJO special methods, and so on. So as I said, simple things are easy, but then there are things that are not easy because there is an impedance mismatch between the languages. This is the first example of such thing. So maps, okay. Maps have methods and properties, and they also have elements. A map is a container, right? Now the problem is that in JavaScript, every object is a map. Every object is an associative dictionary. JavaScript does not have the separation of namespaces. It just has every object has a single namespace, and its methods, its functions have to go in there, its properties have to go in there, everything goes in there. So what exactly happens if you create a new map and then, say, using the square bracket notation, you put an element named size into it with a value of 2 or value of anything else? So what happens when you try to print it? Well, it does actually print the element, because we think that's the most intuitive thing. But then look at that third method there, says print map size and then invokes it. We are smart enough to know that if you're trying to invoke that something, then you're probably trying to invoke a method on an object. So we will actually print 1, which is the size of the map. It has 1 element in it. More interestingly, even if you're using a square bracket notation and not necessarily a string literal, but any expression in it, if you are still immediately invoking, we will know what you are trying to do. But what happens if you try to assign it to a variable and invoke it later? Well, you know what? Don't get smart. It's one of those things where we are trying really hard to make sure that you things work intuitively, but of course you're still able to go around and shoot yourself in the foot. So if I have this guy here, for better posterity, instead of printing 2, I just assigned a string value to the size. And now if we run this thing, see how I'm actually using, wait, let me lift it up a little bit higher. See how actually it prints the expression that's being evaluated and then the value? That's because I'm running everything to this nice little thing, which is a print eval, which prints the expression and then evaluates it. So this evaluation actually goes into the eval, reevaluates the whole thing, but then it manipulates the Java maps, and it all just works nicely and transparently. However, as you can see, these first 2 expressions will return the map, the element in the map, and these other 2 will invoke the method of the same name. And what I said is that you can actually shoot yourself in the foot if you want to, because you can do things like var x equals map size, and you will actually get the property, and then if you try to invoke it, well, you know, so this won't work. I won't even embarrass myself by running it. There's actually not really any well-defined semantics that this could work and still be cheap to execute. Okay. Interop security. Now, if you have been paying attention, and well, in the past year, there were security breaches in Java that Oracle has worked super hard to fix, sometimes even at expense of anything else. So our teams usually, whenever there's a security breach, then the basic protocol is throw away anything that you have been doing if you are anyway related to it and get down fixing it. But quite a lot of these security breaches had to do with Rhino, which was the previous JavaScript runtime that was shipped with the JVM. Now, I did actually work on Rhino in my past life, but I'm not particularly ashamed of the fact that Rhino has a bunch of security holes, because when Rhino was written originally, and that was still well before I came to Rhino, and it was written in Java 1.1 days. There was no security model in Java at that time. Rhino as such was completely agnostic about being, secure. And then some folks, when Java X script interface came out and with Java 6 back then, thought that, well, we should probably ship some JavaScript runtime with the, or any script runtime with the Java X script interface, because we are shipping an API and it doesn't have any implementation, and they put Rhino in it. So that unfortunately opened a big can of worms, figuratively, almost literally. And so with Nashorn, at least, we are super conscious about paying attention to security. Our tests all run under a security manager. We have a very small subset of tests that are trusted, but most of the tests actually run under a security manager. So with Nashorn, you can only invoke public methods. When you run under the security manager, you will only be able to access objects and classes from non-restricted packages. So sun.misc, sunmisc, unsafe, and so on are unreachable. Also, you won't be able to access class and class loader or anything from reflection package or dynamic invocation package. You can, however, correctly invoke color-sensitive methods if you need to. Again, this only applies if you're running under a security manager. So this applies to JVM running in a browser, JVM running in a multi-tenant enterprise environment with policies. If you're just running JVM as your backend system, if you don't have the -d Java security manager system property on your command line when you launch Java, then this does not apply to you. So most backend most backend installations of Java are actually, this is actually relevant to them. Okay, so what else can you do when you are working with Java? Sometimes you need to extend Java classes or implement interfaces. Well, this typical Nashorn code, you saw it in the previous action listener example as well. You can just say new Java lang runnable, pass it a object literal, and in the object literal you can have properties that are functions that implement the methods in the interface. It doesn't even have to be object literal, right? It can be an expression. You can build that object separately and then just pass it to the constructor. We also support a nice little syntactic extension. I mean, if I'm just quickly alternating between these two slides, then you can probably notice that the only difference is the placement of the curly brace. And there actually needs to be an additional closing parenthesis, but pretend I didn't say that. So this kind of a syntax is actually close to the Java anonymous, well, not just anonymous, like inline inner class subclassing syntax that we support because Rhino supported it as well, so we don't want people to feel too unfamiliar with it. Even simpler Nashorn code, lambda style, is if you have an interface that only has a single method, then, as I said, you can just pass a function to the constructor. Similar to this one, right? You can implement multiple types. The way you do it is you use this, you see this java.type. That's actually a way to address a type in Nashorn. In the previous example, I was just using Java lang runnable as identifiers on the top level. That works too. I tend to prefer using java.type because it's safer. I'll get back to it. And we also have another capital J Java function named extend. We did actually decide on having capital J Java as a global object, which is the entry point into everything platform specific. So we didn't want to litter your global JavaScript namespace with a bunch of different names. We just grouped everything within a single object that exposes the API to Java, and this is a capital J Java. So capital J Java extend, if you pass it on a list of types, which, well, one of them can be a class, and all the others, at most one can be a class, and all the others have to be interfaces. It will create you a proxy class that implements all the interfaces and maybe subclasses that one particular class. So the thing on the left-hand side is actually a proxy class that implements both the iterable and runnable interface. And then, you know, you can just instantiate it with new and pass it an object literal that defines your method. There you actually have an internal new iterator thing as well that's doing this. As with everything that's doing this. As with everything, I have oh, there it is, multiface. I have this in a demo form. So here I take the types, extend it. Here I have the object literal that is both a runnable and an iterable. And then here I'm using it as a runnable. I'm passing it to a thread, starting the thread and waiting it to terminate. And here I'm using it as an iterable. I'm just passing it for each. And then if we run this thing, then you can see that it will print running, which means that it was invoked on a thread as a runnable, and the same object was then used as an iterable, and we have iterated over it successfully with this, with its 3 elements that are coming from this array literal here. Alrighty, so this is how you can implement multiple types. The question of this and super when you're extending Java classes naturally comes up. What we decided is the JavaScript this in the adapter methods is the JavaScript object that's defining the functions. So the thing between the curly braces there. That way, if your run function depends on this, says this.y, it will actually get the y that is defined there in the object literal itself. So it's not returning you the proxy, which is the r, which is assigned to the r variable. So that this, in these cases, will always be the object itself. This is pretty much the only useful way to define this. You could be, I mean, we could have decided to use the proxy itself as the this, but at the end of the day, I mean, what use is it, right? It itself does not contain any state. It itself, I mean, what are you going to invoke on it? System identity hash code? It's not really good for much else. If you really feel like you need it, then of course, well, you assigned it to the variable name r, so it's still there. If you are passing lambda-style functions, then obviously you don't even have a JavaScript object as a variable binding context. In that case, it just does what every function invoked in JavaScript would do, which, when invoked on its own, which is it prints global. Because global is the this for the functions where they're just invoked on their own. Or alternatively, if the function is strict, then it's undefined. Then it's undefined. Yep. So this one, I'll disregard the other ones that I commented out, is that if you run this on its own, you see that you get the object global as the value. And if you actually say that this function should be strict and you run it, then you're actually getting undefined, which is as it should be. So which is as it should be. So these are by definition, these are by design. And as I said, if you really need to get that runnable instance, then you know, you can just use the variable name to get to it. Super is weird. We do actually have two ways to invoke super methods. Fortunately, you don't really need to use them a lot. So let's suppose that you're subclassing filter writer and you want to capitalize everything that goes through it. What you need to do is you need to override the write function, and this is the way you do it. So we are not implementing an interface here. We are subclassing a Java class, right? And so the write function is something that is overriding a function from the filter writer. And let's suppose we are just shipping it off to some capitalized function that knows what to do, but you need to invoke the super method. So the canonical way you do it in Nashorn is at the bottom of the screen you have the java.super, which if you pass it a proxy, you are getting back another proxy that is only invoking the super methods on that particular instance. The drawback of this is that you need to define a variable in the same scope where the capitalizer is, so you might be scoffing at the need to have an additional variable. We were thinking about being able to like sneak it into the object literal, but that unfortunately does not work. Because by the time this second line executes, capitalizer has not been initialized yet, so syntactically this doesn't fly. And we also have this alternative syntax, which I expect most people will actually be using, which is you can just prefix a method name with super $. Okay, here's a confession. I personally don't like that. But then I know that most people who are writing JavaScript and want to like have quick scripty usage will resort to this because it's just at your fingertips, right? You can just write super $, and you're done with it. You don't have to remember to initialize a separate variable. I don't like it because it's polluting the namespace of methods where it shouldn't. But yeah, what can you do? We also use it because it's compatible with Rhino again. Nashorn, as a rule, is not Rhino compatible, so you won't be able to take your large Rhino-based project and just run it with Nashorn. In most cases, you will, but there is things that you will definitely run into. But where it makes sense, we preserve compatibility. This is a compatibility preserving measure. Security, and I'm coming back to security a lot in this talk. Again, you can only extend public classes and interfaces you can only override public and protected methods. I mean, yes, you can override protected methods, obviously. You can do it in Java as well. So in Java, you can also take a class, subclass it, take a formerly protected method, redeclare it with public, and then just delegate to it as a super, right? So it's not it in itself is not a security hole. All right. So when you do the interop with your underlying platform, you do need to convert values from time to time. And JavaScript is like the ultimate fun playground when it comes to this thing, because that expression there evaluates the string 10. Obvious, right? I mean, JavaScript. So we do the type conversions mostly. So when I say type conversions, what do I mean? I mean converting to Java primitive types and to Java strings, so to Java ints and Booleans and doubles and strings and arrays and lists and maps. And this usually happens when you're invoking a Java method on a POJO, and it has a parameter list with its types, and you need to coerce the incoming arguments. So there are things that are mostly trivial. So that expression in the first line, it basically tells you, retrieve me the type of the Boolean arrays and then create me a new one with a size of 1. If you think this looks ugly, then you should have seen how did it look like in Rhino, which will I show you. And then I wrote this little test function, which is taking various variables and then printing what they become when you shove them into a Boolean array. And you can do this exercise for any primitive type and see what happens. But I can tell you what happens. Things are sometimes grim. So 0 is converted to false. All right, 1 is converted to true, fair enough. An empty object is converted to true because in JavaScript rules, 2 Boolean conversion says any object is true. An empty array is true for the same reason. I have the nagging feeling that an array that has a sole element which value is false would actually evaluate to false, but I would have to test that. Now, the empty string evaluates to false, but the string with the word false evaluates to true. Yeah, JavaScript. Only empty string converts to false when treated as a Boolean. Any other string converts to true, even the one that has the word false in it. It's like one of those psychological tests when they are flashing words of colors at you and asking what color are the letters. So they'll flash the word blue at you and it's in green and you're supposed to say green, right? It's almost like that. It's like, quick, what's the value of the string false when converted to Boolean? Yeah. So null and undefined, they became false. Now, if I change this a little bit and I'm using a capital B Boolean, then the only difference is that in that like hideous magenta color there, that null actually gets converted to null and undefined gets converted also to null. That's because the capital B Boolean, it actually has 3 values, right? People don't think about it, but it does. It has the value for true, it has a value of false, and any reference of the type can actually have the value of null. So so when converting to box types, we actually preserve nulls. Again, if the target is a sum type, but I'm beating you to death with this, is that, hey, look, you can pass functions in places of SAM. So like if you're sorting a collection, you can just pass a comparator there, there as a 2-argument function. Same thing with a thread. Oh, this was also a very ugly thing, is you pass a function to a thread. Now, obviously, you would think that, well, the logical thing to do is treat this function as a runnable and initialize the thread with it, because that's what you would want to, right? Now, in early versions of Nashorn, we were actually getting an overloaded method selection error here, because thread has 2 constructors. It has more, but let's consider these 2. It has one for runnable and it has one for string, because you can construct a thread and give it a name, and you will figure out the runnable later. So, you know, a computer is just is only as smart as we program it. So at that point, we didn't really program Nashorn. This was about a year ago, I think, to be smart about it. So it did surprise us with a, well, you know, I don't know. Are you trying to pass me a runnable, or should I take this function, which in JavaScript is an object, and every object has a string value, and every object is implicitly convertible to string. And would you like me to take its string value and use it as the name of the new thread? So we realized that if you are adding conversions to your language above and beyond what the Java language allows. And boy, are we adding them. Any object can be a Boolean, you bet. It's JavaScript. So we actually needed to set up rules for prioritizing conversions that go above and beyond the Java rules. So now it will actually go to the runnable because it says, well, here's an interface and it has a constructor with an interface. It's more likely that you want that one. Yeah, what I said. Strings, numbers, and Booleans. So boxed string, boxed number, and boxed Boolean will be recognized as primitive JavaScript number, Boolean, and string values, as a matter of fact, although the engine internally these days tries really hard to use ints and primitive values whenever it can, and we're actually doing a lot more of that work right now. But but you can also invoke methods on POJOs, right? So you have a string foo. It is actually an instance of Java-lang string. So can you invoke a POJO method on it, say hashcode? Yes, you can. Whether this is useful or not, I'll leave it up to you, but you know, for sake of consistency, it has to work. So the JavaScript string type does not have a method named hashcode, but the Java string type does have one, so you can invoke it, because the thing on the left side, even though it is a primitive, even from the point of view of Nashorn, it's treated as a primitive JavaScript string value. From the point of view of Java, it's still a string, and it's an object. You can invoke things on it. Which brings us to the most fun part, which is arrays. So arrays can be nasty, right? I mean, there is not really a big consensus in different languages as to what is an array anyway. In Java, an array is a fixed size, fixed type container, so, which is to say all elements of the container are of the same type. I mean, granted, the type can be object, but still everything in it has to be then a subclass of object, right? And it's dense. It's usually allocated as continuous, but it doesn't have to be the case, so that doesn't matter. But compare them to JavaScript arrays. Those things are like, you know, when you look at the poor little Java array, which just sits there with its size and one type, the JavaScript array looks like something that would have to be put on a loud cover of a comic book saying, like, you know, the incredible growing and shrinking array, because it can grow and shrink. The incredible polymorphic array, because it can have values of many types. The incredible sparse array, because JavaScript, they can be sparse. You can just initialize an array, and they set element number 3 million in it, and all the others are not defined. So if you have your wits about you, you probably won't even allocate the space for them. With a Java array, you can't do that. If you want an array that has element number 3 million, you will have to allocate an array that can hold all the others that come before it, right? So how do you convert between these two types? And our initial reaction was, well, we don't. I mean, seriously, we don't. I mean, do I want to take responsibility for a conversion between two very different types? So this thing in the first line, this was not supposed to work. You will notice that I'm talking in the past tense. There's a reason for that. So we suppose that if you try to pass a Java native array to a Java API that requires an array, we will just reject it. We'll say, can't convert. And we provided an explicit conversion API to, so java.to, which if you pass it an array, it will, by default, it will create an object array out of it. It will allocate an array, copy all the element, you get the idea. Because I was thinking, a JavaScript to Java array conversion will always have to create a copy. It's an operation with linear memory and linear time requirement. No way in hell I'm doing this implicitly for people. So, but it turns out that, I mean, API design is always a trade-off, and we did this, and then people started using Nashorn in anger. They were porting various kinds of server-side frameworks and so on, and they got caught up on this really badly. They said, well, I know that I'm passing something to a Java API that expects an array. Why the hell are you not converting this automatically? And I tried to reason, it's like, well, you know, it's dangerous, linear time, linear space, and they said, no, we want this to work automatically, so it now does. for better or worse. So we changed the decision. We do provide automatic conversion now. We also try to listen to community feedback, which apparently we can do. So this is now actually supposed to work, but the thing down there is also also still works, because sometimes you maybe want to create a Java array and not immediately pass it to a Java API that expects one, so you can just do your conversion. Manually. So if you just do this, then oh, actually, var toString equals Java util arrays toString. As you can see, what I'm doing here is I'm actually taking a static method on a utility class, and I'm assigning to a variable, which you can do because methods are become first-class functions in JavaScript. So I can now just do so. I said this should now work. Now the thing is, it doesn't. Why? Because we can convert to any array. And so the Nashorn will tell you, yeah, so what do you want me to do? Do you want an int array, an object array? I mean, it looks like an int array, but who knows? Maybe you want a double one. And this method is very radically overloaded. So by using Java 2, you are actually forcing it into an object array, and at that point, ambiguity goes away, and this thing will work. Or, maybe I'm adding something, and, this still works because this is an object array, but I can actually pass another argument to Java 2, and if I say, okay, I want an int array, and then as you can see, the value a becomes a 0, because in JavaScript, again, a string that cannot be converted to int when you need to do a to-int conversion becomes a 0. If I wanted a double, things would be much more shiny. I will get a not a number, which at least is a little bit more honest. So, this Java 2 actually works for lists and DQs and any array type, and the default type is object. Now I actually do have a small like demo code here in Eclipse that I did this little array printer class, which has a method named printArray and the one named printlist and yet another one printMap, and I will show you that you can actually pass an JavaScript object to any of these, and they just get automatically converted to whatever. Map is particularly interesting, right? So if I do, I actually have it somewhere. Oh, saw that. I'll just so var print array is, I need my Java type of Nashorn demo. What's its name? Array printer. Print array. Now if I do print array, it does run. So that line saying print array, this is actually that's actually coming from here, right? So or I can also take the print list. I don't even have to assign it to a variable. I can just, I mean, this is ugly, but it works faster. I can just invoke it. So you can say, like A, B. And it did actually say print list. So it means that the thing on the right side is actually the list being invoked. And, I can even do this, print map. And if I do a print map and I'm passing an array, you will see the true nature of a JavaScript array, that they are actually maps, right? So they internally are assigning 0 to A, 1 to B. I mean, make no mistake, we are doing efficient internal representation. So when you're allocating something as an array, we will, depending on how do you populate it, we'll actually have an array in the background. If you're just chucking ints into it, we will actually start out with an int representation. So we are trying to be efficient about it. But that's implementation detail. On a purely specification level, an array in JavaScript is a map. So, conversion to list is actually funny because if you want to do Java 2 array, say, here's a two-dimensional array, okay? And I will want to convert it to a type of an array of lists. Why? Oh, of course, because it's not a Java. Oh, it's not two array, it's only two. Okay, so I got something, and if I get the class, Java class name of X, you can see it is an array of lists. So it goes to say that X0 is an instance of Java util list. Yes, it is. So as you can see, the conversion to the array is actually, if you're doing a multi-dimensional array, you are asking for a, or I mean, you could be asking for a multi-dimensional array. The conversion goes recursively. So it says, oh, you want an array of lists. Great. So I will get an array of lists, and then every element I will have to treat as a list and convert it accordingly. So in this case, your two-dimensional array actually became an array of lists, which is gray actually became an array of lists, which is quite nifty if you think about it. So that's the conversion. Of course, component type conversion show you that if you're converting, say, if you're converting a string 55 to int, you will actually get 55. But if you're converting a word, that's not a decimal number, you will get 0. Okay, what else? Statics. So you are a Java programmer, right? You do understand the difference between, this is a different topic, of course, between a Java IO file and Java IO file.class, right? Who understands the difference? Okay, all right. So basically, the first one, the second, okay, let's start with the second one, that's easy. It's an instance of JavaLang class, which is the runtime representation of a particular class in the runtime. The thing on the left-hand side is a name of a class, and in Java, the language, in a source code, this is a completely compile-time construct, right? It does not exist at runtime. It's completely compile-time construct. It serves two purposes. It provides a namespace for static members, and it's used as a constructor. That's the two things it does. It is completely distinct from the class object, and it's not reified at runtime. So they're completely separate concepts. They should not be mixed, and they probably shouldn't be mixed in other languages either. A lot of languages did actually, the dynamic languages on JVM mix them up, but we do not. So you will be able to do things like, say, var file equals Java IO file. This is sort of like an import statement. You can now refer to it as file. And then you can use it to invoke static methods on it. You can use it to invoke it as a constructor. You can use it with the instance of operator in JavaScript. But it is not the same as what you get if you actually have already a file and you do a get class on it. So the next to last line saying f.getClass triple equals file, nope, does not equal. The funny thing here is that while in JavaScript, in Java, you had this purely compile-time construct. In JavaScript, you don't have compile time, so these objects that are used as the namespace for the static members and a constructor actually have to be reified at runtime as well. But they are not class objects. They are something else. They're an internal thing, but you don't have to think too much about it. Just something to know about to not get caught up in it. Inner classes. So in Java, you can do things, you can declare inner classes, and the static inner classes are less interesting. The inner classes that are bound to an instance of an outer class are more interesting. So say that we have a class of a farm and a dog can decide whether he's home at a particular farm, right? This is how you at a particular farm, right? This is how you declare it in Java. And I have this marvelous example here with the addition of reasonable two strings. And if you go back here and I say var farm is Java type Nashorn demo farm, and I say McDonald's farm, new farm, and I print it. Yep, it's the McDonald's farm. Now I want to create a doc for the farm. Now in Java, you would write something to the effect of McDonald's farm, new dog, right? Now the problem is that this can't really work in JavaScript because new is a reserved word, cannot appear on the right side of the dot, and so on and so on. So we're actually going for a, so this doesn't work, right? It's a syntax error. It can't work. So we were thinking about what to do. So what you can do is you can do this, and you can pass the outer instance as an argument. This is actually how it looks on the JVM level. So when inner classes were defined in Java, they did not really percolate the changes to the JVM level. So on the JVM level, the constructors for these classes actually do look like this. So you need to pass them an explicit instance of the outer class. So this is how you can do it in Nashorn. And indeed, if you ask the dog if he's home at McDonald's farm, he'll tell you that yes, he is. Yep, that's pretty much how you use it. You can also, when you're doing inner classes, you can also just take the class itself, and you can also tell this, and then you also get it. Or you can also use the $, the JVM syntax form, or as you could see up there, you can just, if you already have an outer class instance somehow, then you can just use the property notation to get it. These three expressions all give you the same result, which is the class for the dog, which then you can invoke, and then you can say like var McDonald's dog 2 junior is new dog, McDonald's farm. And this little guy is also at home at McDonald's farm. It's also at home at McDonald's farm. Okay. And my last topic here is JSON. So this was actually discovered by, I think, Ben Evans at the Nashorn hackathon in March in UK, related to the Devox UK, where he was trying to print out some POJOs as JSON objects, and so, you know, let's take a simple Java object, a bit set, right? You take a bit set some bits in it, and let's print JSON stringify and see, you know, what do we get? You know, what do we get? So, JSON, or it's POJO JSON. So here's this very same example. So let's just first print the first line, and what do we get? Undefined. Ouch. Well, it doesn't sound too promising. So what do we get if we try to sneak it into an object literal, right? Let's just see whether it works correctly. So if we have an object literal has a property named A assigned to something, and we sneak in the B, let's see what we will get, right? So we need to see the object literal now. Let's see what we get for B. Woo, it doesn't even show. So we do get the A and hello, as you would expect it, but the B is just gone. It's not there. Why? Well, we try to look into it. Turns out we are specification compliant. ECMAScript 5.1 spec says only native objects, array, strings, number, and Boolean, are allowed. Everything else must be undefined. Okay, so our next thinking was, well, let's look into how can we maybe extend the syntax, and then I just read the next sentence of the spec, and it says, it is not permitted, verboten, for a conforming implementation of JSON parse to extend the JSON grammars. So, you know, for better or worse, and I like well-defined specifications, we can do it. We are not allowed to extend the grammar. We must treat everything as undefined. So, you know, apparently you cannot, your POJOs cannot be serialized as JSON. Oh well. Now, the thing is, you can sort of do it because JSON, stringify, and parse methods actually take 2 additional parameters. Actually, stringify takes 3, which is for handling of space, but let's ignore that one. So stringify replaces a function that you can use to replace any value, including custom objects such as POJOs. You can replace it with an alternative rendering. And then you can write the dual of that function and then use it in a parser as a reviver. And that's pretty much what you can do. So here's the one where I did the same thing, except that I interjected this replace bitset function here, which basically says, if you get a value that's an instance of a Java util bitset, then I'm creating a new object literal that has this __ kind key. Sorry, can't really do anything better. It has to be a JSON object. And then I'm passing an array that has the list of the set bits. Now, if we run this guy, Oh, wait. Oh, of course, yes, because I need to run it with the function. Let's repeat it. Here, as you can see, it did actually produce this custom rendering of the bit set where it said kind, it's a bit set, and then I said bits are rendered as bit 3 and the 5 are rendered. Okay, so if I want to get back this guy, replace, revive, I also need to write another function which does the reverse operation. When it's given one of these JSON objects, then it actually can recreate a Java util bit set and read its bits and set them back. So if I run this second example now, you will see how, okay, I rendered it, and then I parsed it back, and after I parsed it back, you can see here that I assigned it to a variable named b2 with the reviver. Says b2 is a bit set. It also has its toString is 3.5, and is it equal to the original b? Yes, is it equal to the original b? Yes, it's equal. It's the same one. Now, of course, you could ask, why don't we give you a universal POJO serializer to JSON? The answer is, we can't. There's no good enough semantics for doing it. We don't see into that POJO. I mean, what would you like to see, right? Yet another serialization framework? I guess not. JSON doesn't deal with cycles. JSON doesn't, well, not with cycles. JSON doesn't deal with anything that's really not a tree. Even if it's just a directed acyclic graph, if you have an object that can be read on multiple paths, it will be expanded into a tree form. So unfortunately, we cannot give you this piece of interoperability out of the box. If you want to render POJOs to JSON, you will have to write your own replacer revivers. Maybe somebody will come up with something that is good enough and works in most cases, but we, as the people who are shipping the engine, will not be endorsing any of those half solutions. So there you go. But this is actually, I wanted to include this in the talk, because sooner or later, if you're writing anything remotely non-trivial, these days you will be either parsing or emitting JSON. And if you're trying to do it with your POJOs, if you don't know about this thing, you are in for a nasty surprise. And maybe you will spend hours debugging it, and then you will heap curses on my and my colleagues' head for writing such a dumb piece of software. But unfortunately now you understand why we couldn't. All right, yeah, we did all of this. And finally, I want to talk to you a little bit about packages. Again, one of those funny things in Java is that packages, again, they don't exist in the JVM, right? They're a purely source-level construct of the Java compiler. It's the part of the name of the class that is, before the last dot in the name. A running JVM cannot determine whether a package exists or not, because you can have a class loader anywhere in your system that might be able to load a class with a particular package at any given time. Or maybe it cannot now, but will be able to in the future. Maybe it's pulling out classes from a database. Maybe it's fetching them over HTTP, right? There is no closed enumeration of all the packages that might exist at the runtime. So when you are doing this thing in the bottom, which is actually very convenient, saying var list equals new Java util array list, what Nashorn does is a so-called stepping stone pattern, where we give you a top-level Java object, which when you try to retrieve any property on it, we will treat it as a package. So java.util, it must be a package. Java.util array list, and then we actually try to resolve it and say, hey, look, we have a class. And then you can instantiate it. The problem with this is that if you mistype it, and for some reason you have a typo, so instead of an array list, you are writing a code and talk like a pirate day, and you get carried away and you write array list, then as soon as you try to instantiate it, you will get a class not found exception. But we cannot give you that exception ahead of time, because if you write a non-existent class name, we must presume that, might be a package. So that's why I encourage people that if you can and you care, for your quick and dirty scripts, it doesn't matter. But if you want to have larger maintainable software written in JavaScript, what am I talking? Try to try to use java.type, because java.type takes a string and it always has to be a complete class name. There's no packages involved. So, and it's a little bit faster because you don't have to evaluate it like Java, get a property on Java util, get a property array list on Java util. You just pass it a string, evaluate it at once. If it exists, you get back a class. If it doesn't exist, you get back an error. I think it's much more maintainable. Also, what it does and what the other syntax cannot give you is it does actually understand arrays and multiple dimension arrays and so on. So you can actually use it to retrieve a type for an array. So if you say Java type int square brackets, you actually get back an object that represents the class of int arrays, and then you can use it as a constructor and constructor with a size. Back in the Rhino days, the Java lang reflect array new instance was the only way you could instantiate a Java array in JavaScript. So I think that compared to that, we did actually improve quite a lot. Security, well, you know what, I don't really want to rehash it. Just probably have it 3 times in my slides because I really feel it's important and I really want to tell you about it, that we are making sure that this thing is secure. I had all of this on a previous slide. Java type also won't let you access classes in restricted packages. There is a special permission Nashorn Java reflect that you can specify your policy file if you're running under Security Manager that will let you actually do reflection if you really need to, but think twice about it. So, all right. That was all I had. I hope that this presentation was helpful to you. So if any time in the future you expect that you will lay your hands on Nashorn and be writing JavaScript code that interoperates with the Java runtime, and you're doing it with Java 8 and it's built in Nashorn, then, well, as you can see, whenever you're trying to marry a language and an existing runtime system with some assumptions, you will have some rough edges. We tried really hard to smooth those edges as much as we could. You know, sharp rock protrudes here and there, but this is really only the cases where there's really only a few cases where you couldn't do anything. For the most part, I think that we try to make it so that everything should work, everything is intuitive. There are a few pitfalls and things that you have to be aware of, which are just the differences between things, how JavaScript interprets things and Java interprets things. All right, well, thank you very much for your attention. That's all I had. Question?